Hey everybody, and welcome to today's session. In this session, I want to talk about infrastructure as code, and I specifically want to focus on Azure Bicep and Terraform. So my name is Sarah Lean. I'm a Senior Cloud Solution Architect with Microsoft. I'm based in Scotland, so I'm very proud of my Scottish heritage. I have been in the IT industry for about 18 years, give or take now, and I've been focusing on that on-prem environment quite a lot throughout those years, looking after data centers, looking after servers, hardware, being an Exchange expert, all of the things that you're used to on an on-prem environment. And over the last maybe 6 or 7 years, I've been focusing more on cloud technologies. So thinking at the very start of it, I started using Microsoft 365 and moving people to there as an Exchange platform and then as a productivity tool. And recently I've been focusing on Azure and talking to customers about how they can adopt Azure and move their environment there. So I've really been on an evolution myself with my career and my path as well. Now, I'm active across all of the social media platforms. You can find me on all of them. But the place that I'm probably most active and consistent about approaching is my blog. So techielas.com. You can find lots of tutorials I've written on Terraform, Bicep, infrastructure as code. There's lots there for you to grab a hold of. So please head over there, subscribe. You'll get notified of posts that I put up. And yeah, there's a comment section so we can interact there as well. So yeah, check me out on my blog is probably the best place to get me. Now, today's agenda inside the session, as I said, we want to talk about infrastructure as code. We'll be diving into what problems it solves, what it is, how you can use it, and then we'll be diving a bit into Azure Bicep and Terraform and showing you what those languages look like and how you can pick between them and use them and integrate them into your environment as well. So if we think about deploying resources, whether that be in the cloud or whether that be in-prem, it can be quite a complex process. There are lots of things that you have to do to configure like a Windows server. There's lots of things you have to do to configure an Azure virtual machine. And trying to deploy things consistently, time and time again, just as an individual, can be quite tough. And when you start to think about that as a team and trying to, delegate tasks to other members in your team, keeping that consistency is even harder. And of course, you can write documentation, you can write checkboxes so that people can walk through them. But again, as human beings, we are prone to making mistakes, and often that can be quite a slow process as well. And let's face it, when we look at technology these days and we look at the graphical user interfaces that we have for, say, Azure or AWS, they are constantly changing. You can log in one day and a checkbox is on the left-hand side one day, and then when you log in the next day, the checkbox is either gone or maybe is on the right-hand side. So keeping that consistency and keeping your documentation up to date is often hard. And so we really need a solution that can solve that consistency, can help us be more repeatable, and to actually reduce some of the overhead that we're taking to be able to deploy our resources. And this is where infrastructure as code comes in. Now, the official definition of infrastructure as code is that it's the process of managing and provisioning computer data centers through machine-readable defined files. So it can effectively deploy everything that you need in that consistent manner. It solves that problem. We don't have to look at documentation and figure out which checkbox that we actually have to tick. We don't have to think about the naming convention and do that correctly when we're manually creating resources. Our infrastructure as code can help us solve all of those challenges, and it can help us with the delegation of deploying that infrastructure as well. If we think about traditional splits inside your IT team, it's often your infrastructure team that have to deploy everything, and your developers have to sit there and wait until those resources, that infrastructure, is deployed before they can then deploy their code. If you create infrastructure as code, you can give that kind of files, that template to your developers, or give them access to the system that can deploy your infrastructure as code, and they can deploy it. They can do it in a consistent, repeatable way, in the way that you've defined, meaning that you no longer have to have that process of waiting and things like that. So there's the delegation aspect to it as well. There's lots of benefits to infrastructure as code. If we think about infrastructure as code, there are a ton of code languages out there. So on my slide, I've got things like Terraform, Ansible, AWS CloudFormation, Pulumi, Puppet, Azure Bicep Crossplane, and that's just some of them. I think I've named all the ones on the slide. But what I want to do is focus on, as I said at the start of this talk, Terraform and Bicep. Those are the ones that I've been learning over the last few years. So in 2023, I learned about Terraform, and that was the focus for my learning journey. And in 2022, I focused on Azure Bicep. So I've spent a lot of the last 2 years looking at infrastructure as code, and specifically these two. So let's take Azure Bicep to start off with. Now, Azure Bicep is an open source infrastructure code language that Microsoft created. So it's a first-party tool created by Microsoft. But as I said, it's an open source tool, so the community have been helping Microsoft create it and build on it and add features and functionality over the last few years. Now, Bicep isn't the first infrastructure as code tool that Microsoft have launched. It's ultimately the new iteration of Azure Resource Manager, or ARM templates, as we've heard about them. And that was the original infrastructure as code language that Microsoft created when they created Azure. Now, ultimately, the Azure Resource Manager is currently what runs Azure in the back end, and that's what's used to do a lot of the large deployments. So Bicep just builds on top of Azure ARM to deploy it, but it's now a domain-specific language, so it's a DSL, Bicep, and it uses a declarative syntax to deploy your Azure resources. Now, for those of you that have maybe heard about ARM templates and dismissed them as something to use because of the complexity and the kind of not nice structure that they were written in, you might be more comfortable using Azure Bicep, and we'll show you later on what it looks like and why it's a new version and why it was developed. So as I said, Bicep was created by Microsoft, so it's a first-party tool, and with that in mind, it's there to integrate with your Azure resources. So things that you want to deploy right off the bat, you can deploy. So Azure Policy, template specs, blueprints, virtual machines, app service plans, all of that functionality that you need to deploy the Azure resources that you've currently maybe got or you want in your environment is available. But thinking about one of the benefits, and this is often the differentiator of Azure Bicep as a first-party tool versus the third-party tools that interact with Azure, is that from day one of a new product or a new feature launching, Azure Bicep should have support for it. Now, it sometimes happens a couple of days after, but ultimately, because Microsoft know about a new product that's coming along, they can build in support from Azure Bicep. So that means that it has that information instantly about what's happening with the product as well, unlike some of the third-party tools. So they have to wait till something happens and is delivered before they can start to build support. They don't have that inside scoop as to what's happening to build that support into their tooling. And this is where I see a lot of customers actually use Azure Bicep alongside a third-party tool. So if a new feature or functionality comes along that they instantly want to use, they instantly want to start testing, they want to deploy it inside their production environments, they can use Azure Bicep and they can use that alongside a third-party tool. So I've got lots of customers that use Terraform as their main deployment tool, but then they use Azure Bicep for some of the newer features and the functionality that maybe Terraform does not yet support. So it's great for being able to use that instantly off the bat for new features. So Bicep is free. You don't have to pay anything for it. It's just there. It's a free tool that you can use. You don't consume anything. You don't have to pay for it. Free and open source. That's the two key words that I want you to remember about Azure Bicep. So Azure Bicep allows you to divide your code into small, easy to manage pieces that we call modules. So each would deploy a set of resources, and that ultimately simplifies the deployment, allowing you to reuse code across your projects. And you can easily add modules from one Bicep file to another Bicep file and start to build up that repository of code that you have. And ultimately, that's what I've been doing during my learning journey. I've got code that I've created, and then I take that and use it into other parts and to build up more complex deployments. I've got smaller bits and add it on, and then that has helped me with my learning journey. I can help you with your reusability within your organisation as well. So if one team develops a module and has really good working code, and you want to use it, you can share that with each other, hopefully, inside your organisation and help each other with that learning journey and with the actual deployments within production as well. One thing that has helped me with my learning journey is actually writing my Bicep inside Visual Studio Code, which is a code editor, a free code editor from Microsoft. And out the box, it helps really well with Bicep, but there is an extension that Microsoft have created that you can install inside Visual Studio Code that again gives you additional support. So it can help you with snippets of code, it can suggest code for you, it can help you complete a line. So if you start typing, it can then help you complete what that code line should look like. And it helps you with things like highlighting certain sections of your code or colorizing it, again, to help you with that authoring experience as well. So I highly recommend using Visual Studio Code and the extension, the free extension, to be able to write your Bicep to code as well. So it's beneficial, especially when you're learning this new language as well. So what does it look like? So here is a bit of Azure Bicep. And we can see here, it's quite short. This is all we need to create an Azure storage account. And I counted it, it's 11 lines of code. And this will create, if we deployed it, actually an Azure storage account. So let's break it down and explain what's happening here. So the first line of code tells Azure that you're trying to deploy a resource, and that resource type is a storage account. Now the part that says Microsoft.storage/account, storage account, and then the date is actually referencing the API version that we want to use to be able to deploy that resource. Now I think this might be slightly out of date, there might be a newer version of the API, but ultimately you can use any supported API here if you want to get some functionality or consistency within your environment. The next line is defining the name of the resource. So in this instance, we're going to call it Toy Lodge Storage. And then we're declaring what location, so which Azure region or data center we want to deploy this resource to. And we're using West US 3. Then we actually define the SKU type that we're going to use. So a standard LRS storage account, so a local redundant storage account. And then the last little section actually says we're using the Gen 2 storage account type, and we're using the access tier of the storage, which is hot. So that's the bare minimum you need to deploy a storage account. There's obviously a lot more functionality and a lot more things you can define with a storage account. However, that's the bare minimum that you need to be able to deploy a storage account inside Azure. Hopefully what you can see from it, even if you're brand new to Azure and brand new to Azure Bicep, is that it's very readable from a human viewpoint. And the syntax format isn't too confusing. There's not a lot of extra brackets or commas or troubleshooting to do. It's fairly simple and fairly straightforward, hopefully, to be able to actually create and start to build up your Azure Bicep templates and deployments as well. So let's have a look at Terraform. So Terraform is also an open source infrastructure as code tool. It's been developed by HashiCorp. So it allows you, again, to be able to define and manage your infrastructure resources as code, and enabling you to automate them, the provisioning and the configuration of it in that repeatable and scalable way, just like any other infrastructure as code tool and language that we have. Now, one of the things that we have to think about though with Terraform is it can actually support a bunch of different platforms and providers. So you can write Terraform that deploys AWS resources, Azure resources, Google Cloud resources, and even some of your on-prem infrastructure as well. So that's a key differentiator. Whereas Azure Bicep only supports Azure, Terraform can support multiple cloud providers and your on-prem environment. So it gives that scalability and that differentiator with it. It's also a declarative language, so the same as Azure Bicep, so it has that functionality as well. So if we think about the benefits of Terraform, why would you pick Terraform? So as I said, it can actually deploy resources to multiple environments, multiple cloud providers. And this means that you can have the same tool and build up consistency within your environment. So if your team learn Terraform, then they can write Terraform for Azure, for AWS, for Windows, for VMware. They can build up that platform, they can build up that skill set and reutilize it. You're not having to use a different tool. So if you're used to using Terraform for your on-prem environments and you're moving into the cloud, then you can use Terraform for those cloud deployments. Now the code is different, so you can't take your Azure code and then just change all the references to Azure to AWS and it'll work. You do have to understand the syntax for each provider. However, you can take that skill set of knowing how Terraform works, how the syntax is written, and be able to use that with different environments as well. So that's something to think about when you're picking an infrastructure as code tool or evaluating it. Just like Azure Bicep, Terraform supports modularity. So again, meaning you can create little chunks of code that you can reuse and share between projects and teams. So again, building up your momentum, building up your knowledge base, and building up that repository of reusable code that's deployed within or configured within the way that your organization wants it to be. One of the things that I found while learning Terraform is that the community is really large. There's a lot of information out there. I've used YouTube community videos, I've used GitHub repositories, blog posts, I've talked to people on X or Twitter over the year, and I was able to do a lot of learning free of charge with the Terraform, and then go and pass the certification. So there's a HashiCorp Terraform Associate exam that you can pass to kind of prove that you know Terraform. And I did that all through free resources from the community. I used a lot of official resources as well from HashiCorp, but there's a large community of resources available to you, and lots of people there willing to help you as well on that learning journey, or to help you understand why something isn't working within your environment. So that's something to bear in mind with when you're picking again a infrastructure as code tool. Is there support there to help you with your journey on that? Now, taking a look at what Terraform looks like, this is an example of Terraform, and we're doing exactly what we did with our Azure Bicep template. We're creating an Azure storage account. So there's 18 lines of code here. Not a lot of difference between our Azure Bicep and our Terraform template. So that's a good thing. That's a good thing that they're both compact and you can look at them. So if we break this down, let's take a look. So in the first 4 or 5 lines of code, it's starting to establish what Terraform providers you need. Now, a Terraform provider is essentially a plugin that interacts with an API. So in this case, we're telling Terraform we want to interact with the Azure provider or the Azure API instance in the back end to help deploy our resources for us. And the next section, the section at the bottom that starts with resource, is telling Terraform to deploy a storage account. So we're declaring the storage account name, just like we did inside at Bicep. We're specifying a resource group this time to deploy our storage account in. We're specifying the Azure region and the type of storage account. Again, a hot standard LRS storage account there. So again, the bare minimum information has been provided for this Azure storage account, but you can see, hopefully again, that this is also fairly straightforward to read as a human being. Again, whether you're new to Azure or whether you're new to Terraform, you can probably guess what's happening and quickly understand what is happening here within this code. And that's really good. That's good from anybody's case in point, from learning these languages to getting it to grips with more of the complex code examples. And let's face it, this is a very simple example. And when you start to do production deployments, these code lines are going to get beyond 18 lines, they're going to get beyond 11 lines, and they're going to get more complex. So the easier to read that it is, the better for everybody involved, especially when it comes to troubleshooting something that's happening inside your environment. So let's take a look at some infrastructure as code best practices, and regardless of what infrastructure as code language you're using, let's take a look at some of the best practices that you can apply to them. As with any code, storing it within a version controlled system is the best way to provide an audit trail of code changing, giving people a better collaboration experience and allowing things like peer reviews to happen. So using things like Git and GitHub Actions or Azure DevOps to be able to store and version control your code is something that you really need to think about. Now, infrastructure as code can help reduce the amount of misconfigurations that are made when deploying resources. However, it is still possible to misconfigure using infrastructure as code. What I would suggest and what is really thought about is start to look at things like static analysis scanning on your infrastructure as code base that can help detect any misconfigurations according to your business best practices and needs within your organisation as well. Use the tools that are available to you to be able to make your infrastructure as code much more robust and reliable as well. I think one of the most widely agreed upon best practices for code, whether it be infrastructure as code or just code, is to avoid deploying credentials, secrets, important stuff inside your code. Don't put your username and password in clear text inside your code. The recommendation would be to use things like a secret manager. So something like Key Vault if we're in an Azure environment, or maybe the AWS key management service, or something like HashiCorp's Vault that can all do that for you. So make sure you're thinking about storing your secrets, that important information, in the relevant place, so some kind of secret manager. If we look at things like Azure DevOps or GitHub Actions, there are places inside there that you can store your secrets as well. So just think about how you want to control those kind of important information, that sensitive information that you need to call on. Something that I've talked about before, I think, is documentation. Some folks say there can never be enough documentation. Other folks say you don't need to document infrastructure as code at all because the code itself acts as documentation. Now, of course, the truth of it is somewhere actually in between. So for me, your documentation should focus on sharing knowledge and transparency for your code. Think about the people behind you that are going to have to interact with your code. Think about the junior people in your team that might need documentation to help them get to a more mature level with their code as well. Or even just think about yourself in 3 months' time or 3 weeks' time when you come back to that code. Will you remember what you did? So make sure you're being transparent and sharing your knowledge within your code, whether that be embedded in the code itself with comment lines or whether you're specifically creating some kind of documentation. Think about it and make sure there's a correct balance there. One of the great things about infrastructure as code is it helps you with that consistency. But in order to make it probably more efficient, you need to use or should be using something like a continuous integration or continuous deployment, or CI/CD if we prefer the acronym, tool to be able to automate that for you. So again, looking at something like Azure DevOps or GitHub Actions to be able to store your code and then deploy it by triggering it. Something happens inside your environment, triggers it, and it'll run that code for you, or manually doing it. But yeah, think about something like a CI/CD pipeline to be able to help automate the deployment of your infrastructure as code. Now, I work with lots of customers who are using Azure every day, and they are thinking about their strategy of infrastructure as code. And often I get asked about which one's better, Azure Bicep or Terraform, which one should I use? And while I don't think they necessarily compete against each other, like I said earlier on, I think there's times when they can be used together within your environment. Let's have a look at them and compare them just for to get that question of Bicep versus Terraform out of the way. So both languages use the declarative programming paradigm. So it defines the desired state of the target. It describes the intended goal that has to be reached. The other programming paradigm out there is imperative, where you define the specific commands that need to be executed to achieve the desired state. But in this case, Terraform and Bicep both use declarative. So you ultimately just state the type of the state that you want to reach at the end of the code generation. As I said earlier, Azure Bicep only supports deploying things to Azure, whereas Terraform can deploy to multi-cloud providers and some of your on-prem platforms as well. So again, that's a big differentiator for a lot of customers, having that consistency of being able to just use one infrastructure as code language across the piece. And as I said, from a community standpoint, both are fairly large, but because Terraform has been around since 2014 and Bicep's only been around since 2020, Terraform really has maybe a bigger one or can be considered larger, but both are very open, very active, and there's lots there as well for support if you want or need it within your learning journey. Terraform and Bicep differ in how they handle state. So Terraform stores state in a file that tracks the resource modifications and serve as that single source of truth, whereas Bicep takes state directly from Azure and does not need state files. So with your Terraform state file, it can be stored locally if you're just working on something in a demo environment or a learning environment. But when you're doing larger deployments inside your organization, you'll want to store that file in a backend. So something like Azure Blob Storage or Amazon S3 storage, Google Cloud Storage or HashiCorp Cloud can be used for that. So you have to think about that as well and maintaining that backend with Terraform to have that single source of truth. Whereas with Bicep, you don't actually use that. It just uses the interaction with Azure to be able to tell you what's happening and how your code would need to be changed or what your code would do to change that environment. So to summarise, Azure Bicep is a Microsoft developed infrastructure as code language. It's free and it's open source. Terraform is the infrastructure as code language that allows you to interact with multiple vendors, and that was developed by HashiCorp. And try and find a balance with your documentation. Make sure you're helping yourself and others when you're writing code and for the future as well. As I mentioned, there's lots of resources that can help you, and I've pulled together some things together. So if you have a look at aka.ms/IEC with Sarah, there's links to things that I've created, some official documentation and links beyond. So please do check them out and see how they can help you as well and further your learning journey with either Terraform or Azure Bicep. Thank you so much for tuning in, folks. I really do appreciate it, and hopefully you found this session really useful to you, and you now have an understanding of not only what infrastructure as code is, but what Terraform and Azure Bicep is. Thanks again, folks.